Alright, today we're going to go over algebra, for algebra 2b, we're going to go over page 91, 1, 2 to 36 even. We're going to use over all these exponent properties. So the next thing I'm going to do is put a picture from page 88. So this is from page 88. It goes through all the properties and the names they're going to talk about. Remember, I kind of gave different names. For example, I really focused on, like, with product of power, with this property right here and this property right here. Notice the bases are the same. When the bases are the same, you add. If it's multiplication, you add the exponents. And if it's division, you subtract the exponents. Here, you notice they're very similar. The bases are different. And there's parentheses. You're probably going to just use distributive property. I call that like the distributive property for exponents. Negative exponent property is really important. Remember, I was thinking that more of like opposite, because I don't want you to get in this habit of thinking a negative exponent means a negative answer. It doesn't. It actually means repeated division, not repeated multiplication. It's like the opposite. Power to a power, if you have an exponent to an exponent, right here, you're going to multiply those exponents. So that's this one right here. Zero exponent, anything to zero power is 1. And that's about all of them. I think we just have all of them. All right, number 1 says name the property. A, we have a to the m times a to the n equals a to the m plus n. That's the product of powers. Remember, I'll just say same base with multiplication. B, we have a to the negative m equals 1 over a to the m. Now they add a can't be 0. Obviously, you can't have 0 in the bottom fraction. So that's called the negative exponent property. Remember, I like to say opposite exponent property. So if you don't like negative, you can always put opposite. And I also like to point out in B that if you have 1 over a to the negative m, you can move that fraction, if it's a negative exponent, you can move it upstairs to make it positive too. So that works both ways. And then C is a b to the m is a to the m b to the m. That's the power of a product. And I just said that's more like that's kind of like the distributive property for exponents. All right, that's it for number 1. All right, number 2 is 25.2 times 10 to the negative third in scientific notation. No, because the number here, the number to begin with, it must be between 1 and 10. So you would actually have to move that decimal place over to make it 2.52 times 10 to the negative second, because when you move to the left, it adds a number to that exponent. Negative 3 plus 1 is negative 2 is correct. All right, that's it for number 2. All right, so the first thing I'm going to do is I'm going to do power to power. And I'm going to multiply negative 2 times 3 to get 4 to the negative 6. And then I'm going to do the negative exponent. To get 1 over 4 to the 6th. And then my final answer is going to be 1 over 4 to the 6th, or 1 over 4,096. All right, and that's it for number 4. All right, 6, I'm going to do the power to a power. Or just think exponent to exponent. And I'm going to get 2 to the 8th, which is going to be 256. And that's it for 6. Number 8, I have 3 over 5 to the 4th. I'm going to take, this is the power of quotients, if you're using the book name. Or I'm going to use distributive property for exponents, where I'm going to take the 4 to the top and the bottom. I'm going to end up with 3 to the 4th over 5 to the 4th. And if you actually want to write that out, is 81 over 625. So that's it for 6 and 8. 10, I have 9 cubed times 9 to the first. So 9 cubed times 9 to the negative first. So I'm going to do the product of powers. Or, I like to say that they have the same base. So they have the same base, so that base stays the same. I do 3 plus negative 1 to get 9 squared, which is just 81. Now number 12, there's a bunch of different ways to do number 12, or I mean not necessarily a bunch, but a couple different ways to do number 12. So I think what a lot of people might do, and it really doesn't matter, is I like to say, technically these are matching bases. Inside the parentheses are exactly the same, so I can use the product of powers, and I can do these two bases can just stay one base, and I can do negative 5 plus 4 to get 2/3 to the negative first power. Now I can use the power of quotients, or I like to say the distributive property for exponents. And I take the negative 1 at the top and the bottom. I end up with 2 to the negative first over 3 to the negative first. Now the negative exponent property is going to tell me to take that 3 and move it up, and take the 2 and move it down. It's going to become 3 over 2, or 3 to the first over 2 to the first, and that's it, 3/2. Alright, number 14, we have 1/2 to the negative 5th, all squared, and I'm going to make this 1/2 to the negative 10th, and that's going to be the power to power. And that's it for 14. Alright, so number 16, because this is all multiplication, so it's all multiplication, I can move things around. I don't FOIL, okay, don't FOIL. So I can do 1.2 times 6.7. And I can do times 10 to the negative third times 10 to the negative 7. So I do 1.2 times 6.7. I end up with 8.04. That's still in scientific notation. If that was less than 1 or bigger than 10, I would have to re-put it in scientific notation in another step. Times, I have matching bases, so I add the exponents, 10 to the negative 10. 8.04 times 10 to the negative 10. And that's it for 16. 18, I have 7.2 times 10 to the 9th. Next to 9.4 times 10 to the 8th. So once again, I'm going to do 7.2 times 9.4. So I do 7.2 times 9.4. I end up with 67.68. Now I'm going to do 10 to the 9th times 10 to the 8th. That's times 10 to the 17th. This is not scientific notation because this number is bigger than 10. So what I'm going to have to do is I'm going to make it, so I'm going to move the decimal 1 to the left, which adds 1 exponent. So I write 6.768. So now that isn't scientific, and it adds 1 to 17, which makes it 10 to the 18th. So it adds 1 exponent from here, adds 1 to make it 18. So that's your best answer right there. 6.768 times 10 to the 18th. All right, number 20 says we have 4.0 times 10 to the third, all to the fourth power. Now, because these are both products, you have to distribute the 4. The 4 has to go, so I have to do 4.0 to the fourth times 10 to the 12th. 4 to the fourth is 256 times 10 to the 12th. Now remember, this is not scientific, So I have to take 256 and I have to move it over. So I'm going to left 2 decimal places, adds 2 exponents. So that 12 is going to become 14. So it's 2.56 times 10 to the 14th. And that's it. All right, so I'm going to do 1.1. It's 1.1 times 10 to the negative third, all over 5.5 times 10 to the negative 8th. So I'm going to focus on those two. I'm going to do 1.1 divided by 5.5. I'm going to get 0.2. So that circle right there turns into 0.2. Now I'm going to focus on this chunk. I'm going to have 10 to the negative third, and then I'm going to subtract negative 8, which is going to make it negative 3 plus 8, which is, so now it's times 10 to the 5th. This is not scientific because 0.2 is less than 1. It has to be between 1 and 10. So I actually have to take this decimal place right here and I have to move it over to the right. Now, so 1 decimal place right means subtract 1 exponent. So that 5 is going to become a 4. So it's going to become 2.0 times 10 to the 4th. And sometimes they won't make you put the 0.0. Sometimes they will. It just depends on kind of how picky and how they want their scientific notation. So that's it for 22, and I end scientific notation. All right, 24, we have w to the negative second over w to the 6th. So the first thing I'm going to do is I'm going to do my same base. Now, if you want to call it the book on page 88 says the quotient of powers, but I just think same base, so I'm going to subtract the exponents. I'm going to do w negative 2 minus 6 is negative 8. Now I'm going to use the negative exponent property. And I'm going to get 1 over w to the 8th. All right, so 26, there's a couple ways you can do this. What I'm going to do first is I'm going to do I'm going to distribute the negative 1. I call that the distributive property for exponents. If you want to use the power of products title as well, it's okay with me. So p to the negative 3, q to the negative 2. Since they're both negative exponents, I'm going to put 1 over p cubed, q squared. And that's the negative exponent property. And that's it for 26. All right, 28, there's the first thing I would do, and there's some other ways to do this, but the first thing I would do is I'd like to take the negative 3 to everything. Even though that 5 there, it's still 5 to the first, so that 5 also gets the negative 3. So I'm going to make this 5 to the negative third, s to the 6th, t to the negative 12. That's a 5. If you can't see, that's a 5. Now, so that's our, I call that, like I said, I call that the distributive property for exponents. Or the book's going to call it the power of products property. Now you're going to use the negative exponent property. And you're going to make 5 and t go downstairs. So s stays on top, s to the 6th, so this guy stays on top. And these guys right here go downstairs, 5 to the positive third, t to the 12th, which is going to be, best answer, s to the 6th, all over 125, t to the 12th. All right, and that's it for 28. All right, number 30. I always look for matching bases first. So I notice that the x's are matching, and that means I'm going to subtract those exponents. So I'm going to do x to the negative 1 minus 2. And now the y's, they also have matching bases. So the y's are going to be 2 minus negative 1. So the x is going to turn into negative 3, and the y is going to turn into positive 3. So that's, I call those right here, this property, I just say that's the same basis exponent property, but the book calls it the power of quotients property. Now, I'm going to use my negative exponent property, and that negative 3 and the x is going to go downstairs, so it's going to become y cubed all over x cubed, and that's your final answer. Alright, so number 32, we have 4r to the 4th s to the 5th over 24 r to the 4th s to the negative 5th. So the first thing I'm going to do is I'm going to cancel out the r's match and these s's match. So I'm left with 4 over 24, which that's going to simplify down to 1/6. And that's it for 32. Alrighty, so 34, very similar to what we've done before. I'm going to make everything one big fraction bar. And I'm going to kind of line some stuff up. So I'm going to put 8 over 4 first. I'm going to put the y11 over the y7. And I'm going to put z to the 7th over z cubed. 8 over 4 just turns into 2. Now I have y to the 11th, y to the 7th. That's my same bases. And I'm going to make that y to the 4th. Z to the 7th over z cubed. Same bases again. And I'm going to make that z to the 4th. And that's it right there. 2y to the 4th, z to the 4th. And that's it for 34. 36, what is the simplified form of 2x squared y all over 6x y to the negative 1. So once again, I'm going to focus on stuff. I'm going to focus on the numbers. 2 over 6 as a fraction. I'm going to change that into 1/3. So I already know I'm going to have 1/3 from the 2/6. x2 over x, 2 minus 1 is just, you're going to have x on top. So that's the quotient. That's x squared over x is just x to the first power. So that's why it's on top. Y over y to the negative first power. So this part right here, 1 minus negative 1 is 2, so it becomes y squared. So your best answer is x y squared all over 3. And that's it for 36. So that finishes this assignment. Remember, 2 mistakes on purpose. Those are your accuracy problems if this assignment is late. And remember, this is going to be part 2.1, part 1. There will be a second part to this. All right.